to this edition of our series of Hangouts with Sigma Xi's distinguished lecturers. I'm Fenella Saunders. I'm the managing editor of American Scientist magazine. And this series will continue every 2 weeks or so. And we have our next one coming up on December 2nd, when we'll talk to Mark Cerise about climate change. So please make sure to look for that and come back for it. This talk is sponsored by the Research Triangle Park chapter of Sigma Xi. So hello to everybody in that chapter, and thanks for watching. If you have questions, you can submit them during the discussion, either in the Q&A window that you should see to the right of your screen. If it's not up there, there's a little grid of boxes at the top of your screen. You can click, and Q&A is an option. You can post them on the event page. You can also send them to us on Twitter, and we'll get them that way. And if you are a Sigma Xi member and you wish to ask follow-up questions after the discussion, you can go into the communities page, the lab, and there's a discussion thread there called Let's Talk About Innovation. You can post your questions there and we'll get them to the speaker. And also, this video will be available for watching after we're finished, so you can let your colleagues know to watch it later if you want to pass it along. But today, we're really excited to have with us one of Sigma Xi's distinguished lecturers, Dr. Karen Oates of Worcester Polytechnic Institute, and she studies the science kind of behind innovation and deep learning. And thank you so much for joining us, Dr. Oates.
My pleasure, thank you.
Great. So your research background is actually not in this field. You actually studied cancer, if I remember correctly. But so one question we always wonder about is, how did you get interested in the topic of studying, what lets people be innovated? How did you start in there?
So it is interesting. I did spend the first part of my career working at the National Institute for Health, doing research at George Mason, all on the ability of cells to progress and what cell progression looks like in a malignant state. But once I got out of the lab more and more, and I joined the federal government as the deputy for undergraduate education at NSF, I really started thinking deeply about the environments for learning. What kind of environment should we be thinking about? And I looked at different institutions across the United States and in foreign countries, and thought how different some things are from one institution to another. And what does that mean? Because I believe as a scientist that form follows function. And if we have a certain form, we're going to come out with a different type of function. So innovation, that ability to create a new way of looking at something that has both value and function, was something that kind of came about as an evolution from a bench researcher to an academic administrator. When I joined the NSF, we were thinking about developing a program that we were going to call BIN, Boosting Innovation Now. And during that time, I really started to read deeply about what type of environments you would need to boost innovation. What are the signs of innovation? What are the different types of ways of thinking that let you think about something in a new way, and that new way has some value? That's what an innovative environment is thinking about something differently. So I did a lot of research and work on trying to create a program for the federal government to look at how colleges and universities across the US and abroad could really create something different. Let their classrooms look different, have their laboratories look different, so that we would be practicing innovative procedures with them, with our students. So for instance, I think, being a scientist, many of my colleagues will absolutely understand that there's probably nothing worse than having laboratories in which it's a cookbook and the students have to follow a process and they have to do the same thing that the student did last year on week 2, and the following year the same procedure, the same experiment would be run with an outcome that we already know. I mean, for me, that was a way in which we could just collapse any innovative power that we could give our students. So looking again at form following function, how do we create environments that allow a student to really have free will, yet let them learn some of the very basics that they needed for the science that they were involved in. So it was through my federal government work, when I was thinking about things in a much bigger way than what was happening in my little space, that I really became interested in creating innovative environments.
Right, okay, that makes a lot of sense. But I think one of the things we might do here to help people understand context a little better is maybe we could define what we mean by innovation. I mean, everyone has a sense of what it is, but how do you really encapsulate it?
So textbook-wise, really, it's about creating something new or looking at something in a very new way. And that new thing has value. So there's a value piece put onto innovation that you may not see in other aspects like entrepreneurship. This one means that you have seen something different in something that's already there or something that is being created, and that has value. It's like connecting the dots. I can see dots and I can connect them, but what I need to do is I need to see things that aren't even there yet and start to make some connections. And that's kind of an innovative way of thinking. So one of the things that's important is to think about how we help our students think. Do we have them think about things in a very divergent way? Or are we trying to teach them to do convergence thinking? And for me, I've always thought that in order to create an innovative environment, you need to have, first, a divergent thinker. What are all the possibilities? What are all the crazy ideas? What are all the things that are very different from that norm? And then you say, okay, from all of the possibilities, what are some things that make a lot of sense? What things have value? How do we now move this into an environment in which we have a lot more constricted possibilities? So it's divergent thinking, move to convergent type of thinking.
Right, that makes a lot of sense. So you were saying before about connecting the dots, and I actually was curious about that aspect of things, because when you read history about people who have made really important inventions, there's often cases where there was somebody before that person who kind of got there but didn't quite connect all those dots. I was wondering if you could talk about why some people connect those dots and others don't. Do you think that's an inherent trait, or do you think that's something that can be learned?
So I believe that it is something that definitely can be learned. I don't necessarily think it's inherent. I think some people just have a propensity to think a certain way. But when we have our students who have been in a classroom since they were 5 years old and 4 years old, up until now, if we aren't giving them the freedom to think, the freedom to take a real risk in being able to connect two things that we might not guess would be related, then we're actually in a mode to constrict their innovative thinking. We're also constricting their creativity all at the same time, which I think these two things go hand in hand. Motivation and free will, I think, are very much part of the innovative process. And I'm not so sure I never would have connected those things in such a meaningful way. But if you think about a student who has free will, that makes us as teachers, quite honestly, a little uncomfortable, because it means they have more voice. They have more control on what is going on in the classroom than if I was just getting up and telling the students what I know about a particular subject. I think one of the most daring things I've ever done is only write half a syllabus for a course. and have the students write the second half. And that's what we'll do. That's free will. That free will motivates the student to think differently. It also helps them think about being almost an expert in something. They have confidence that they can do something different. They can connect the dots. Rather than saying, this is the way I think, you must think like me. And those are the environments I'm talking about that are really important in a university and in a classroom. It doesn't have to be in a classroom. It could be outside the university. It could be in the way clubs are run. It could be, you know, the amount of time a student spends in the classroom is actually quite small compared to all the learning they could be doing outside of the classroom as well.
Right. Yeah, that makes a great amount of sense. I mean, a lot of people talk about how learning happens in more active environments than in a classroom setting. So I would think that you'd need to incorporate multiple settings that have a really effective experience.
Yeah, two things on that. One is you're exactly right. Again, it's form follows function. If you don't provide the form of learning and motivation and free will and having a student feel as if they can be an expert, you're not going to get the function you want. So, I mean, you have to be very careful. Designing your classroom is really an extremely important part of the university's activities. It's not necessarily something that you think about in grade school, but it should be even more important in a more fully formed brain to be making sure that you're using all parts of it. The second part of that really is that many times innovations come from necessity. And having students have an uncomfortable environment, for me, is not such a bad thing. Putting them in a situation they've never been in before, but giving them the confidence to be able to solve whatever it is that's before them, that problem that this unusual environment gives them, really helps them, again, with that kind of divergent thinking, and then having to solve the problem, which means you have to converge onto something. You have to actually do something. And my experience on this lies when I went overseas to the Republic of Georgia with some students many years ago. And they were students from a university who had lots of equipment and lots of instrumentation, and we were doing some work on water. And they partnered with students from one of the universities there. And those students didn't have the same equipment. They didn't have the same environment, yet they had to solve the same problem. So they went about it in a very different way than my students did. And I thought to myself, wow, that was pretty innovative what they did. You know, that was a really good way, and I wondered if my students would have been able to figure that out, because I'm not giving them some uncomfortable environments, some environments in which they don't have everything in front of them. They have to figure it out themselves. So those are two kind of examples of really what brings me to the design piece of innovation.
Right. It's actually kind of interesting that you're talking about discomfort for people. I think that sometimes, you know, unless somebody is already a famous inventor, if they're coming up with sort of an innovative solution, sometimes they may not even realize what they're doing is revolutionary until somebody else says, wow, you know, this solves my problem too. In some ways, getting that kind of feedback can really make or break somebody who's trying to be innovative. And on the flip side of that, there are plenty of historical cases where somebody was innovative and everybody said, oh, no, you're just crazy. What are you doing? So can you kind of talk about the reinforcement and feedback aspect in innovative circumstances?
Sure. I think one of the powers that partnerships have is undervalued in innovation. Diversity is undervalued in innovation. And when I say diversity and partnerships, what I'm saying is if all of my students come from a very privileged area and they, with many different things in front of them, then they're really not going to be able to see things they don't see. So in a partnership, they'll be able to identify from the experience of others something different, something that they missed. So I like to put together teams that go out to solve a problem, but that problem is one that could be looked at from many different angles. So forming partnerships and forming diverse teams become a real priority. Again, form follows function.
Right, okay. Do you think that part of teaching students to be innovative is somehow giving them the confidence to trust their own decisions in a solution they're coming up with?
Mm-hmm. Things like free will allows students to take the risk in an environment in which they're not going to be, they're not going to fail a grade, lose their scholarship, all kinds of stress that's put on them. We know stress isn't actually has anything to do with being innovative. Stress is stress. But giving them that kind of environment in which they are a part of solving something that has meaning, that will help society, that will solve a big problem is going to be key. It's not as though I think you have to teach a course on innovation. That's actually not where I come from. I come from the idea that says, here are many things that we can be doing in our classroom with the content that we have, in the time period that we have with our students, that will give them some of those skills that allow them to connect dots in ways they didn't know even existed. So you could be teaching a course on cell biology, or you could be teaching a biochemistry course. You could still create an environment in which students are practicing the skills of innovation. Not until they come up with the problem that's relevant to them will they maybe use it. But you've got to be able to give them the freedom to do things a little bit differently without such high risk, in an environment that is not so stressful, and one that kind of takes in their intrinsic motivation. So intrinsic comes because they do it for its own sake. And I think that maybe not everything is intrinsic, but you can come as close as you can. You can start connecting things to something that has really great meaning to them. So those are kind of the environments that I think are really important for the student.
Mm-hmm. Yeah, absolutely. So I want to play devil's advocate just for 1 second here, because we had defined innovation, but there's this old adage that everything old is new again. So I'm wondering if you think it's really possible for people to still be innovative. I mean, are we always just kind of rehashing things, or is it possible to really come up with new ideas?
Oh, I absolutely think it's possible to come up with new ideas. I think we haven't even explored all that our brain can hold for us. I mean, certainly every day we're confronted with new problems in the world. Certainly today being a day after the Paris attacks, just think about the different things, the different problems that are going to arise, a different environment. People are going to have to think differently. So I think every day presents ourselves with some really great tools for innovation.
Right, okay. So you've been talking about creating kind of a student environment for innovation, but I wondered if you can kind of talk about ways that those environments can be stretched across other areas as well, in industry or other places, not just for students, where you can create an environment that fosters innovation.
So with industry, one of the things my industrial partners will tell me is one of the best things for them is bringing in students who know a little but don't know as much as they do, but then have a nice discussion with them about what they think could be a solution. So partnerships are clearly important to industry. Bringing in a fully firm bringing in a mind that is fully formed, however, may not have all of the content that they have allows them to look at something in a very different way, to look at it in a way in which is not the norm, because they don't know what the norm is, and to sit down, you know, face to face with other scientists and engineers to look at a problem in a very different way. So these kind of partnerships with different skill sets and different, even generational changes, I think are really important. My industrial leaders would tell me there's really nothing more exciting for them than to sit down with a bunch of young people who have studied the same subjects they have, but studied in a very different way, and let them help the team solve a problem.
So do you think that in environments now are, how do they compare to, say, in the past? Do you think that we've got a more conducive environment for innovation now, or was it better at another certain point in time?
I think it's not as good as it used to be. I mean, even look at young children. Young children used to go outside. I used to play out in my yard, you know, until the street lights came on, and then I came home. Kids don't have free time the way they used to have. They don't have time for their imagination. They don't have time to create whole new stories. They're in camp, you know, and unless that camp is centered on innovation or creativity, whatever, it's really not a good environment. It's not the best environment for free will, for feeling like they're going to take a risk and do something crazy. I think it's probably much less, especially for children. All of the standardized testing, which is good in some respects, but really, I don't really know in the long run how beneficial it's going to be. Having some time just to explore, just to pick up a rock, look underneath the rock, and tell a story about what kind of ecosystem is under there. Having them look up in the sky and create their own type of constellation, and tell a story about what that constellation might look like. These are kind of the practices of someone having free will and someone having you know, the ability to hear their voice and to feel good about themselves. You know, I used to teach. I used to have a camp in the summer for younger kids on creativity, and I would just give them odd things and say, "Put it together, and tell me what you made." And you would give them just odd stuff, and they would come up with the most marvelous type of you know, different gadgets. They wouldn't work most of the time, but that didn't really matter. It's the idea is you let them practice. And that's kind of what we need to do in colleges as well.
You're making me feel better about the stories that my 4-year-old tells. So, so how do you think the U.S. compares to other countries around the world in sort of this environment for creativity and innovation?
So if you look at teaching environments, you know, certainly we're better than some of the more, you would say, less democratic, more structured countries. And yet, on the other hand, you know, you look at places like Sweden and Finland, and they really are pretty open, letting the children do lots of different things and experiment in lots of different ways. So I think we're pretty good. We could be better. And I think more and more as we understand the power of innovation, free will, motivating students in a particular way, if we could start to put that into our classrooms more, that would be terrific. It's hard to do that if you're teaching to pass a test, you know, and I know that there's a time when you have to do that, but do we need to do it as much as we do, and do we need to do it as often as we do, and does it need to be such high stakes for the student? You know, these are really good questions our education system has to grapple with. And it's not about ideology, it's all about student learning. It's not about what group you associate yourself with. It's about what is the very best environment for students to learn and for students to take a chance on being that next innovator of the year, being that next, X Prize recipient. So I think those things are really important. I can remember when my children were little and they wanted my kids to do a science fair, and they were young. They were like 4th grade. And I'm thinking, science fair, wow, that's probably like mom and dad fair, all the kids who had parents who were in science were probably going to do really well in this. And I kind of refused, I remember refusing to do this. And I just said, I'm not, I won't be a judge, I won't be involved. But if you have all the kids bring in their collections and have a collection fair, I would do that. And then all their collections get put into little subgroups. So my kids would have shells, and they would bring in all the shells that we've collected from all the beach. And so they would have shells from Virginia, shells from another state. And then they'd have a second subclass that was shells that are pink, shells that are white, And so I kept thinking, well, this is probably a better way to have students think about science. Not that at the 4th grade, they have to have an experiment and run an experiment and have a result. If you don't have a result, that's okay. But just to think about science in a certain way, it's looking at things, trying to connect certain things, putting things of similar things together, things that are very different together. Those are all different ways of thinking. And we have to spend more time on the thinking aspects of innovation and a lot less on the putting down and teaching to a test.
So I think that it's probably commonly known, most of the push towards teaching towards tests seems to be more from the drive we have as a society to quantify success. People teach to tests, and we run tests so that we can run statistics and figure out if we're doing a good job. So if we were to move towards a more innovative environment, is there a way that innovation can be quantified in a way so it's sort of, how can you get at innovative thinking in students and figure out whether or not they're doing that in a quantifiable way?
I don't know that I can do the quantifiable way, but I do think that there is an aspect of critical thinking that you can get to. So I don't think there's going to be a test on innovative thinking, but there could indeed, and there has been in the past, the whole idea that all of this leads to thinking about things critically, giving a set of dispersed information, what can you make from it? And so I would think that something that has to do with critical thinking aspects is going to be much more of value long-term than some of the standardized testing is doing for us today. Mm-hmm. Especially if it takes that spark out of a student who has an idea or has a love or a passion and says, no, let's put that on the shelf, because now we're going to have to study for something you don't really care about or you don't think is particularly relevant to your life.
Right, okay. So one of the things that's commonly cited is that innovation drives economic factors, yet there still seems to be this disconnect between that thought and funding for basic research, for instance. I was wondering if you could comment on why you think that is. Why do you think that it's hard for people to sort of have this appreciation for innovation as an economic factor, but still not want to support it?
Mm-hmm. I think maybe it's because you can't quantify it. It's not something that you're going to get immediate. You're not going to immediately be able to get a result. It's something that may come 40 years later. It may be something that comes immediately, but most likely it's not going to be something that is just so quantifiable. The whole idea about basic versus applied research is, to me, a very silly kind of discussion, because you can't have applied research unless you've had some basic research prior to it. You're cutting off your pipeline, quite honestly, for applied research if you don't think deeply about the support needed for basic research. Basic research is often there because you have a real desire to solve a problem. Really, that's not a bad thing. You know, I had heard a story about Robert Gallo at the National Institutes for Health. At the time, we were trying to identify the HIV virus, and I believe this is a true story, so I'll repeat it. He was at NSF, he was at NIH, and he was really looking at viral consequences to the body, and looking at how viruses and leukemia might be related. So he cared very much about leukemia, and he cared very much about, was there a viral link? And they tried to pull him away and say, no, we need you because you've got this great mind. We need you to be working on HIV, you know, what we now know as HIV, the virus that may be causing AIDS. And he didn't really want to do it to begin with. And someone said to him, gee, you know, why wouldn't you want to do this? And I remember them telling me the story that he said, my sister died of leukemia, and I have a great internal desire to use my knowledge to help understand, you know, some of the properties of leukemia. And, you know, you wouldn't want to take someone away from that. The reality is, because he had such a great motivation, he actually helped solve one of our biggest problems of the time, you know, understanding the nature of HIV. So you don't want to do that. You don't want to move people away from what really is of interest to them, even if it is very, very basic research. You don't know where it's going to take you.
Right, of course. So we've had a question from the audience that I wanted to pass along to you and see if you had a question, an answer for it. This is someone asking, as someone with a background in higher education, the general consensus, at least among my colleagues, seems to be that things are getting worse, that the atmosphere in education is getting worse for innovation. Do you think things are getting worse or better?
So I think things are getting better in our understanding of the environments that help us let our students create in a more innovative way. We're better at knowing about the skills that are required, and we know how to help them practice it. What is not happening is we're not using that to design our classroom kind of environment. So even though we know what's important, we may not be using it. And I think that this is kind of up to the faculty member. I mean, my classroom is my classroom. I really have the ability to do many things in it without permission. So a lot of this is, yes, I am worried that certainly the younger ages, the kids who are in elementary and middle and high school aren't getting even the environment, or the faculty may not even have a lot of the knowledge that they need. At a university, we have the ability to do this. We have to do it. It's our responsibility to do it. But I appreciate the question. With all the different requirements that teachers have, it's almost like every moment of their day, just like our children, are being structured. And when that happens, you are just quenching an innovative spirit.
Right, so it's in some cases, it's as much the teacher as the students that need the help with the...
Absolutely.
Right.
A lot of pressure on them. It's interesting because, you know, teachers are into teaching because they love what they do. They love the fact that they can make this big difference in the life of a student, and they study to do this. They don't study because they're going to make $1 million, you know, in it. They do it because of a true commitment to the next generation. And then we tell them, well, yes, you have that commitment, but you must do as I tell you. that doesn't make any sense at all.
Right. I wanted to just get a little bit more into what you're talking about before with sort of interdisciplinary teams and how that can help with innovation. I mean, do you think that innovation always works better with teams, or do you think individuals can just be innovative by themselves as well?
I think I think an individual can be innovative by themselves. I don't think that that's the most efficient way to do it, or the most effective way, maybe, to do it as well. You know, my IQ is what it is, but if I'm worth 10 people, I've got all that with me. You know, I've got 10 times that. So it's a way of looking at things. It's a way of having the ability to not necessarily just brainstorm, but there's a difference between brainstorming, where it's like all over the place and unstructured. But if you have a problem and you look around that problem from many different disciplines and many different life experiences, you're able to see it in a different way. I only see what I can see. I don't have the same experience someone else has, and I don't see everything they do, and they don't see everything I do. But if we respect that all of that, we're both going to put on the table our very best, we're going to be able to solve problems in a more unique way.
Right. You know, and I believe that that's to be true as well. You know, that if you have a more diverse team, you have more viewpoints, and that helps you see things in ways you wouldn't have seen by yourself. Is that something people have studied? Is that something you can quantify, just how much diversity and interdisciplinary teams can help people solve problems or come up with innovative ideas?
So I believe that there is research on this. It looks more at the critical thinking piece than the innovative piece, because to this day I can't tell you I know how to quantify innovation. I know the skills that are needed, and I know that I could put those skills into a lesson or a class or an environment, an experiment, but I can't quantify it myself. But I can quantify the idea that individually I might solve a problem, give that same problem to the group, and they might solve it in a different way. And that's more of a critical thinking type of environment.
So I wondered if we could kind of delve into that just a little bit more, though, in terms of if you're looking for people who are working in cross disciplines or with diverse backgrounds or across generations, as you've been talking about. I mean, there's this larger question of diversity in science and making sure that people of diverse backgrounds are going into science and other areas. How do you think that that question of diversity kind of fits into this question of increasing innovation?
I think that they're personally, I think that they are directly related. I know from experience that when I have this diverse team, I come up with different outcomes. And those outcomes are much better than if I'm just doing it by myself. I think we have a little bit of a problem in science. It's been very dominated by a group of individuals who think a certain way to be able to pass a variety of different tests to get them to the point that they can get to college and study science. I think that's probably not the best way to form a good partnership with people who think differently. There are some individuals who are just amazing when it comes to taking tests. And there are others who are just amazing thinkers. And what we need to do is get those people together. You know, some people who just approach things differently, who see things differently, who actually have different motivations for wanting to solve a particular problem. And when it comes to innovation, connecting those dots, I can maybe only see a third of the dots that are out there, but with a team, we can see a much better picture.
So I wondered if one of the things you're talking about, where you're saying that one of the ways to foster innovation is to have students have sort of an intrinsic interest in what they were trying to do. I'm wondering if that could kind of feed back into this idea of increasing the diversity of people who go into science, because if you're increasing this intrinsic relevancy of science to that diverse group of kids, maybe they would become more interested in doing science and growing in that field.
Yeah, I think it brings up the whole aspect of kind of community-based science. science that helps a particular community. If you look at a problem in your neighborhood, if you look at a problem in your home, if you look at a problem that is connected to you, William James said the most important thing is yourself. And when you start attaching things that have meaning to you, you have the ability to really think in a very different way, but it's of great importance to you. And I think when it comes to getting a diverse group of people to study science, let's think about where they live, how they live, what are some of the problems that they have to deal with, and show the power of science to solve problems that are of relevance to them.
So if we're talking about people working in diverse teams and trying to use that to increase their innovative powers, what are the best ways for teams to work together? I mean, you mentioned before that it might not necessarily be brainstorming per se. I mean, if you're sitting around a table just staring at each other, that might not be the best time to be trying to innovate. Is it better for people to kind of have general discussions about how they view a field so you get some light bulb moments, or is it better for people to go off by themselves and then get feedback as a group, or are there multiple ways you can do this?
So I certainly think there are multiple ways to do it. My very favorite way is to go out into the environment in which something exists that is of importance. Let's all look at that wastewater. Let's look at it from the point of, here's a factory, here's a wetlands, and here's a lake. And what do we see? What do I see that you don't see? What do you see that I don't? Let's just look at things in a very different way. So it's great to be around a table, and sometimes that works. Other times it's good to take a walk, take a look at the environment that you're trying to problem solve. If it's something that's kind of intangible, well then, sometimes drawing and visualizing something is also really important. You can visualize something in a different way than I can visualize it. And maybe when I see it in the way that you see it, we can start to connect those dots. So I think that surely there's not one way or another. Everybody's different. My students love to learn by doing and having voice and being very active. I believe in very active pedagogies of engagement. That doesn't mean that I actually learned that way. In fact, I was a very quiet learner. I was a person who went to lecture, took notes, and went into the library and closed that little cubbyhole door so I could concentrate. Everybody's different, but that's the beauty of it. Bring different people together to help solve the problems.
Right. Yeah, that makes sense. So we've had another question from the audience, which is kind of interesting because I know in your research you talk about an emotional connection with innovation. And the question is asking if you could comment on the relationship between empathy and innovation, and how might that inform the way scientists view the notion of innovation?
So empathy, meaning an intrinsic kind of understanding of why something is the way it is linked, but not, I don't think of it as a direct link. I think of relevance as being something that is a little bit more tangible than empathy. What I go to is free will. I like the students to be able to study things that matter to them. And my job is to connect that to the science that I'm teaching. So for instance, I'll give you a good example. I used to teach cell biology. I also taught a course called cancer. Well, cancer is cell biology. When I taught cancer, I made sure that all of the elements that I needed to teach in cell biology were still taught, but taught in a very different way when I taught a course on cancer. By the way, this was, for me, a huge innovation. The way I taught was different. For me, all of a sudden, it had relevance to me. There was someone in my family, my everybody knows someone who has had to deal with this. And it was a good way for me to start connecting, oh, this in cell biology means this in cancer. I did the same thing with immunology and HIV. Students cared about learning about HIV. Students cared about learning about cancer. Yeah, okay, they had to take cell biology, and yeah, they had to take immunology, but that's a very different way of thinking about it. The motivation behind everything that they learned was now very different. So empathy, I'm trying to avoid the question, it appears. Empathy, empathy is involved, but I'm not so sure I can connect it in the way I'm thinking.
Mm-hmm. But when you're talking about having a personal connection there to the subject, you know, because people have known somebody who has cancer or something like that, that's kind of the emotional connection that you're getting at there, though. That's sort of the intrinsic value.
Yep, and it's the motivating factor, I think. So so I think empathy helps to motivate, and motivation is a very big part, I think, of looking at things in an innovative way. Sometimes you need to be under a little bit of stress to do that.
Right, of course.
You know, I learned something a few years ago that really shocked me, and I bet other faculty feel the same way. I always would pride myself in being able to teach a course in a way that was very clear, that the student, that I made it so that I could explain it in a way that it was so clear to them that, you know, it was all laid out. How could they not get it? And then I had done some research and looked at some of the other aspects of learning to find that actually that isn't such a good idea. And I think, why is it that helping a student totally understand how a particular mechanism works isn't actually really that helpful to them? Well, the research shows that you have to confuse it just a little bit to let them unconfuse it, to let them learn it for themselves, to put themselves into the answer. You've given them your answer. You've told them exactly how it goes. The reality is, in their minds, they actually have to do it themselves. And I just can remember being kind of shocked and thought, oh my gosh, all these years I've really stressed, you know, these mechanisms and how these mechanisms work. When I taught biochemistry, I would spend hours and hours and hours on one lecture, you know, to find that there should have been a little bit left for them to do.
Right. I guess that makes sense if you're talking about giving them free will, so they have to figure some of it out for themselves. That's sounds very counterintuitive, though. I could see how that would be around.
You gotta be kidding.
Right. So actually, I did wonder about that, though, because when you're trying to teach students sort of baseline knowledge, you know, some of the things you're getting at here, where you're saying you're giving them free will. I mean, are there very specific ways you can work more of an innovation aspect into teaching very basic things? Is it just sort of giving them that applied piece of it, or are there other teaching mechanisms that can help with that?
So I think things like what ifs, you know, so they present you with something and you just say, well, what if? And have them think about something they hadn't really thought about before. Or to challenge them with more debate style types of environments. I always start out, when I teach undergraduates and I teach a very basic science course, I always start out with a case study called childbed fever. And it's, you know, you can find it on the internet, it's used a lot. And it really goes into giving students a little bit of knowledge and then saying, okay, give me all the possibilities. And then you give them another little piece of knowledge. Okay, what doesn't make sense from all of these different possibilities? Until you give them enough that they can actually figure out what the answer is. Those type of kind of protocols really help, I think, the students think about their learning, and they now have to be pretty creative. They have to think about what the possibilities are. Again, it's the what ifs kind of environment you want to create. It doesn't mean that they get to tell you everything they want to learn and you don't have to go over some of the very basic things they may not want to. It's just how you do it. It's, again, form following that function. What do you want as your outcome? If your outcome is for them to be thinking differently, you've got to let them have free will. They've got to be motivated by something. They have to understand the relevance of it in their lives. Those are all important skills that build a innovative environment. So innovation isn't about just one thing. It's a confluence of a whole bunch of things that kind of come together. And it's not an easy job for us as teachers, but it's our job to help them get there.
Right, absolutely. And I mean, we've had some questions about this, but for people who are in kind of a higher education environment, maybe even high school or lower school levels, it might seem a little overwhelming to them to try to think about how to do a major restructure of their classroom setting or their curriculum to create an environment that fosters innovation. But it sounds like there's at least some small fixes you can make that can help change thought patterns, instead of lecturing, sort of helping students deconstruct a problem with you or something like that.
Yes. The first time I started to give students more control in my classroom, I remember, number one, being really scared because it might show my flaws. It might show what I don't know. I did something, and I know a lot of people do this. I taught a freshman course at one time, and I did something called Science in the News. In fact, Sigma Xi has a great website that I had all of the students sign up for, and they had to tell me 24 hours before the class what the topic was that they were going to talk about that was in the news. And I can remember terrapin turtles as being one topic that a student chose, and I thought to myself, I know absolutely nothing about terrapin turtles. And I spent probably, a few hours making sure that when the student might ask a very simple question, I might actually be able to help them, So the Science in the News became this thing where every week, we did it every week. Every week there was a whole group of 20 students who gave me what their Science in the News was. Some of them I was like, yep, I can do this. Other times it was no, but look, they had free will to learn something that they had the ability to find the answers. They could research. They could go into it as deep as they wanted to, but it was theirs. It wasn't my topic. I knew nothing about terrapin turtles. So there's lots of little things we can do in the classroom. We just have to be willing to do it.
So what did you actually use the news stories for in your lesson? Did you have them connect it back to what you were learning, or how did that actually connect to the rest of the class?
Well, the course happened to be called The Natural World. And it was a course that looked at really some of the very basic principles of science. It was a freshman course. And all I really wanted, I had lots of things as my goal, but what I really wanted them to do was read. I wanted them to read science and ask questions, but not read what I told them to read, that they had a whole choice of great articles to go from. So the Sigma Xi Science in the News, it takes things from all over the US, pulls it in. Everything was fair game, and it was just one of those ways for me to give the students a voice and know that they can participate in science. They need to participate with me. Science was something they could do. It wasn't something I did in the classroom and they just took the course.
Right. Yeah.
We're a lot more than courses. Colleges and universities are a whole lot more than courses, that add up to a degree. We're an environment, and that I think, we can't lose that.
Mm-hmm. It's interesting, not to go back too much to my 4-year-old, but I worry about these things with her a lot, with trying to make sure that she sees science as something that's normal. It's not something you have to go and find. It's just something that's there around you all the time. So in a way, I think that's kind of what you're talking about here, is kind of just going out and finding something that connects to everyday life. It's not something that's over there. It's kind of here with you.
And with younger kids, it's so great because they have you can ask them to make up stuff which I think is great. You know, I used to go out, and I'm not kidding, we would go out and I would have the kids pick up a stone, turn it over, and then tell me the story of what went on underneath the stone. They would make up all kinds of crazy things, but it was great.
I think I'm going to try that with mine. I think that's a great idea. We've only got a few minutes left here. We've got about 5 minutes. So I wanted to just switch gears just a little bit and talk to you about another aspect of your research, which has to do with deep learning. Which connects here pretty strongly to a lot of these ideas where you're talking about how innovative thinking can foster learning. So I wondered if we could just talk about that for a minute. So what are some of the principles of deep learning? How do you know when someone is learning something deeply versus just superficially?
So there's again, what I like to focus on are what are the kind of skills that are needed for deep learning. And of course, the National Academy of Sciences put out a marvelous publication on how students learn. And interestingly, they put this out, they came out with recommendations and some very salient results from all of this research. And unfortunately, we as scientists, even though we run experiments and dependent upon the results of our experiment, we change what we do. Chances are a lot of us haven't changed anything that we've done, even though we know a lot about how students learn and deep learning. So for me, it's simply put, it's theory and practice, not one or the other, but both. And getting to a understanding of what the students already know becomes extremely important. My students know that I care about the fact that they are learning and what they're learning and how they're learning it. They know that because I ask them all the time. If you have a class of 200 students, it's difficult to do that. But, you know, thank goodness for these 1 little minute cards, the little file cards where you can ask questions. Take it home. I do this. I take it home. I sit home on the sofa and I just go through them. And then I have an idea about where they are and what they're thinking and how the class as a whole is doing. But I can't lecture because it's only theory. And I can't just go out and have them do without the very basic knowledge there. They have to do both theory and practice. It's actually one of the reasons I joined the faculty here at Worcester Polytech. Their motto is theory and practice. And I love that. As a scientist, it's exactly what I think we should be doing. We should be giving them multiple ways to learn by doing. And they have to have the deep knowledge in order to make connections along the way. So I'm not a person who believes in a whole lot of these survey courses. I'd rather talk to you about cancer, go deep into that subject, and then transfer it to all cell biology. Same thing, you know, about other things. I believe in going deep, getting a deep understanding, and then making the connections. So again, theory and practice is, for me, the only way to have deep learning take place in the classroom. Again, a lot of the same things we talked about for innovation. Students have to, if it's going to be deep, it has to be meaningful. You know, you can teach a subject if it has no meaning to that student. It's not going to go very deep. And I do believe in practice. I believe in multiple ways of looking at something as a way to go deep. And these are all substantiated through the National Academy's work, which is good.
Yeah, of course. Just a quick last question. Two of the things that you talk about in deep learning as being important to fostering that are feedback and self-reflection. I wondered if you talk about why those are important to foster deeper learning and understanding.
So feedback is very important because I've had students get lost in places I didn't even know exist. So if I don't know what they're thinking, I can't help them get out of a corner they shouldn't be in. So feedback is really important. I'm also one of these people who actually believes that a student needs to know when they're doing really well and they can do it, because that self-efficacy really propels them to go further, to go more, to try harder, because they feel they are going to be successful. Everybody wants to be successful. So the feedback is important. I don't want them to get lost in a place I don't even know exists. So I have to feedback right away. And I do very much believe in the whole idea of self-efficacy, especially for our young budding scientists.
So what does self-efficacy mean there, though? If you're having, do they just take time to think about it from after they've learned it, or is it sort of a longer perspective thing? How does that work?
It's how they view themselves as a learner. So the way I think about self-efficacy is, this is the very silly kind of example for you, but I'll give it to you. I happen to be Armenian. My background is Armenian. I once asked my parents when I was a very small child, maybe about 7 or 8 years old, like, so what does this mean? Like, I'm Armenian. And I went into the encyclopedia, because we did encyclopedias then, and I started to read about Armenians. And it said in there, Armenians are usually very good in math and science. In the encyclopedia, it said this. And I remember thinking, well, I'm Armenian. I must be good at math and science. I always thought I would be good at math and science. You know, as someone told me, the encyclopedia for me, which is, you know, the Bible, you know. So self-efficacy is how you see yourself. So if I can help students to see themselves as scientists, as budding innovators, as people who can, you know, see the dots that other people may not see, then I'm really telling them you can do it. And so self-efficacy is how you see yourself. And any way that I can help a student think about how much of how they can contribute to science, and how they can contribute to a team, or how they can contribute to whatever it is we're studying, is okay by me.
Well, I don't want to run long, but I have to ask you just one more question to close us out, because I know that you sort of look at innovation across some very diverse fields, including robotics. And I wondered what you thought about gamification. I wondered if you thought that kind of giving people this sort of game approach to learning help them learn. Does it promote learning?
So it can. I believe that it can. But you don't play a game just to play a game. It has to have a serious learning, cognitive kind of design to it. So if you take, and I love it when I can take a cognitive scientist, a learning scientist who might be doing things like artificial intelligence, that kind of, and a roboticist, and put those three people together, then I think you've got something very special. But to gamify something, to gamify it, is very different than what I would call a serious game, a game which takes into account cognitive development and understanding, and then putting it with robotics. I think that's really fun.
Right, okay, great. Well, we are unfortunately out of time, so I will wrap this up and just say once again thank you to the Research Triangle Park chapter of Sigma Xi for sponsoring this talk with Dr. Karen Oates of Worcester Polytechnic. And thank you very much, Dr. Oates, for joining us. It's been a really fascinating and wonderful conversation.
Thank you. I appreciate it. And thank you to your Sigma Xi chapter. It's great. Thank you.